Okay, so this unit is all about naming chemical formulas, writing chemical formulas, balancing equations, and classifying chemical reactions, right? So today we'll get through the first two parts because they kind of go together. Here we go. Okay, so the first thing that you're going to do is to learn how to name what we call a binary ionic compound. Now you know that ionic compounds are metals with nonmetals, right? The word binary, all it means is two, right? So it's an ionic compound that's made up of only two elements. So think like sodium and chlorine, right? Think magnesium and oxygen, right? If it's made up of one nonmetal and one metal, that's what we call a binary compound, okay? So the protocol for it is this. The cation is written first. So remember, the cation is the one that's positive. It has lost electrons. And of course, what loses electrons? Metals or nonmetals? It's the metals, right? So it's the metal that's always going to come first. The anion is what gains the electrons, and that's going to be your nonmetals. So the way that we name these is you write the full name of the cation, right? So just use this as an example right here. So if I gave you the formula KF, the full name of K is potassium. And then you're going to write the root of the anion. So the root is, so if this element is fluorine, the root of it is this part, right? So you're going to write the root of the anion. And then you're going to add the suffix IDE. So instead of saying potassium fluorine, it's potassium fluoride. And you'll pick up on this because you've heard of compounds referred to over and over and over again where the second element name ends in IDE. Right? And this is standard because this is how we go about naming these compounds. So the second example, here's lithium. So lithium, and then this is sulfur, but the root is here. So instead of saying lithium sulfur, you say lithium sulfide. And that's kind of all there is right now to a binary ionic compound. So let's go through these examples. SrCl2. Okay, so Sr is element what? Strontium, okay.
Strontium chloride.
Yeah, I was just getting there, a little ahead of me. Strontium chloride, right? Here's the root, and then we add the IDE suffix. Take a second, make predictions about the next two. Just write them down. Okay, so Na2O. Chris, what'd you put for that one?
Sodium oxide.
That's right. Sodium with oxygen. Ox is the root, so it's oxide. All right, what about the last one? What did we put for that one? Yeah, Emily.
Aluminum sulfide.
Right, good. Okay. So I'm going to jump a little bit out of order because I'm going to jump to another section which I think makes more sense to follow. So I'm going to scroll and find where it says writing chemical formulas, section 5.2. Okay, so since we learned how to name an ionic compound, let's learn how to write an ionic compound. They go hand in hand. So what we're going to do is when you write a formula, remember the formula is using the symbols that are on your periodic table. So the first thing you do is you write the cation symbol first, so the positive ion first. The anion comes second. Now the thing with this is this can be kind of tricky because you have to determine how many of each ion would be needed, because the charges must cancel out. And by charges, I mean the number of positives must equal the number of negatives, right? Compounds have to be neutral. So, sometimes in order to make these cancel out, you need to multiply one or the other by some number, and that's going to be done by using subscripts. Okay, so, example, sodium oxide. To write the formula for sodium oxide, you need to know the charge on both of these. Sodium is +1, right? And the reason why I know this, there's a couple reasons why you should know this. A, because sodium is an alkali metal. And I probably said more than once that all alkaline metals have a charge of +1 when they are bonded in compounds. Okay? Here, if you don't remember that, no big deal, because on your periodic table, flip it over and look at the back. You've got 3 columns. The first column is metals, and it says what the metal is and what their charge is. Now, all you have to do is you look up sodium, and you see sodium is, the charge is 1. Okay, so that's how you know what charge something has when it's in a compound. The middle column is for the nonmetals. And the nonmetals, for what we're going to be doing, we are only paying attention to the negative charges for the nonmetals. Now, some of these nonmetals have multiple charges. Like if you see, for example, chlorine will say +1, -1, +3, +5, +7. Those nonmetal charges, you're pretty much going to be ignoring the positive charges. You're really only thinking of nonmetals as negative ions. So jot that down on your formula sheet so you remember. All right, only use negative charges for the nonmetals, which is the middle one. There's actually even a note, I think, underneath the column, right? Doesn't it say it's bold? Whenever a nonmetal is bonded to a metal, the nonmetal's charge is negative. Just circle that. And it should make sense that you know that nonmetals are negative, right? Because going back to Unit 3, we talked about how nonmetals have higher effective nuclear charge, how they are able to attract electrons, whereas metals have low effective nuclear charge, and metals usually lose electrons. And if metals lose electrons, that's why they are positively charged. Okay? All right. So, back to the example. Sodium oxide, sodium has a charge of +1. Oxygen, you look up oxygen's charge, it's not -1. I'm sorry, -2. Now, the key point is that these charges must cancel, but right now they do not cancel. So to make them cancel, you're going to need 2 of these sodiums. And that's why the formula is going to be Na with a subscript of 2. That tells us that there are 2 sodiums, because you need 2 sodiums to cancel oxygen's -2 charge. So, try another example. Okay, aluminum. Find aluminum. What is the charge on aluminum? +3. Okay, fluorine, which is a halogen. -1. All halogens would be -1. We had a little discussion about this. Remember how halogens have 7 out of 8 valence electrons, and they gain electrons, but there's only enough space for them to gain 1. That's why the charge is -1. Okay? All right, so I need to combine these in such a way where the charges cancel each other out. Now, because the charge is +3 and -1, you are going to need 3 of the fluorines. So the formula is AlF3. I kind of glanced over this part. Let's highlight this. Subscripts need to be in lowest ratios. So if you, let's say you end up with a ratio of like 2 to 4, that 2 to 4 is really 1 to 2. Okay? If you have a ratio of like 6 to 3, that's still 2 to 1. Okay, lowest ratios for ionic compounds. For covalent compounds, that's not the case. Covalent compounds will be like C6H12, right? That's not a lowest ratio. But for ionic, it's got to be the lowest ratio. Okay, so I'm going to jump back in time and go to our second slide. Okay. Naming ions with multiple charges. I want you to take a look at your sheet, the column on the back of your periodic table. The third column, right? The third column, the first column, metals. Take a look at your metals. Do you see how some of the metals have more than one charge listed for them?
Yeah.
For example, what's the charge on iron?
3 and 2.
3 and 2. What are the charges for cobalt?
2 and 3. Yeah.
2 and 3. What are the charges for gold?
1 and 3.
1 and 3. Okay. So there are lots of metals that have more than one charge, right? Here's the thing. The metals that are in families with names, they only have one kind of charge. Which families am I referring to? Alkali metals and? The metals, right? Halogens are metals. What's the other metal family that we've named? Earth metals. Okay, so the alkali metals and the earth metals, those families have names. Those guys can only be +1 or +2 respectively. The D block elements, chromium, cobalt, nickel, copper, iron, most of the D block metals, because remember the D block, they're all metals because they're to the left of the stairs. Metals that are to the left of the stairs in the middle section, they often have more than one charge that they can be. Meaning they can lose 2 electrons or they can lose 3. They can lose 2 or they can lose 4. All right? And so that's why you see those metals with more than one charge listed. And that's fine, but the problem is when you're writing a name, you need to know which version of the metal that is being used because it changes what the compound is. So, okay. In this example here, iron can be a +2 or a +3. Right? So, if I combine iron with an element like, well, we'll just use chloride since it's mentioned so many times. So, Fe with a charge of +2. Can you look up chlorine for me and tell me what charge chlorine has? -1. So Fe with a charge of +2, chlorine with a charge of -1. We know they must be neutral. So when you combine these two together, you get this formula. Does that make sense? FeCl2. However, we just mentioned that iron can have a charge of +2 or +3. So if I was combining iron that has a charge of 3 with chlorine, and I was combining them into a compound, that compound would look like this. FeCl3. So the problem is, if I asked you to name this compound, you would just call it iron chloride, based on what I've taught you. Here's the problem, though. These two compounds behave very differently, and they're different. They have different properties, so we cannot give them the same name. So how we name them is whatever the charge is on the metal, we use that in Roman numerals. And so this one here would be called iron, and we would use Roman numeral 3 before we use the word chloride. So the name is iron 3 chloride. Okay, again, so the number in Roman numerals, that's the charge. Similarly, this one over here would be iron 2 chloride. Here's a little rule, though, that people tend to forget. It's an important rule because it'll determine whether you get a name right or wrong. You only use the Roman numerals if the metals have more than one charge. Okay, circle that, highlight it, very important. So Roman numerals should not be used all the time, is my point. Okay, so here's an example. What if we have a compound between calcium and chlorine? So calcium, chlorine, I look up the charge. The charge on calcium is what? It's an earth metal, so it's +2, okay. Chlorine, we just showed you, was -1. So the compound between these two would be this, CaCl2. So when I name this, the first step is you look up the name, you look up the charge on the metal, and you have to see, does calcium have more than one charge? Does it? No, it does not. If the metal does not have more than one charge, then you don't need to use a Roman numeral. You don't use a Roman numeral. You just leave it as calcium chloride. The only time you use a Roman numeral is when you need to clarify which version of the metal that you're using. Right? If it has more than one charge, that's the only time you use a Roman numeral. Okay, and this will come with practice. Okay. Okay, so let's try some of these. I feel like we already named this guy, right? So this was iron 3 chloride. Okay, so let's look at the second one. Mn is a metal that is sometimes confused with magnesium. It is not magnesium. What is Mn? Manganese. Okay. So I know that it's manganese, so I'm going to write manganese. But here's the thing. How many charges does manganese have? It has lots of different charges. Okay, so I can't determine what manganese's charge is yet. So what I'm going to do is I'm going to look up the charge on oxygen next. So what's the charge on oxygen? -2. Oxygen is a -2, but hey, notice that there's a subscript of 2, which means in that compound there's really 4 negative charges. And because the rule is that all compounds must be neutral, if there's 4 negative charges in that compound, there must be 4 positive charges to offset it. So I have determined the charge on manganese by looking at the other, by default, okay? So this is going to be manganese 4 oxide. All right. ZNS. Let's look up the charges. So, you know what? Actually, it's probably easier, now that I think about this, it's probably easier for you to look up the charges on the negative ion first. And then use that to determine the charge on the positive ion. So let's do it this time. Look up sulfur. What's sulfur's charge? Remember, only the negative charge that's listed. -2. Okay? So if sulfur is -2, look up zinc.
2.
Does zinc have more than one charge or just the 2?
Just the 2.
Okay. So because zinc only has one charge, I can't use Roman numerals. There's no reason to use Roman numerals. So this is simply zinc sulfide. All right. I'm going to make some space in here, and let's do a couple more. Okay. So try these on your own and see what you come up with. Okay, so the first one, if we look up the negative ion charge first, you look up oxygen, you should see that oxygen is listed as -2. And then rubidium, this is important, the fact that there's 2 of them there. You look up rubidium, it's +1, and you should realize, oh, that makes sense. That's why there's 2 of them, because rubidium is only +1. And then the second question you ask yourself is, does rubidium have more than 1 charge? No, it does not. So this is simply rubidium oxide. Okay, for our second one, look up fluorine. Fluorine is a halogen, so eventually you will not have the need to look up halogens anymore because you should learn they're -1, all of them. So fluorine is -1, and there's 3 of them. So that means the cobalt must be +3, because that's the only way to make that neutral. So then you look up cobalt and you say, all right, how many charges does cobalt have? It has 2 or 3, right? 3 of them? Okay. The point is it's more than 1. So the charge is 3, so you write this as cobalt with a Roman numeral of 3, fluoride. Are you guys understanding when it is that you need to write the Roman numeral and when you don't? Okay, when you need to be specific, that's when you should use Roman numeral. Right? Sometimes you don't need to be specific because some metals only have 1 charge. Okay. Are we okay on that? You want to do maybe another example? Okay. And well, there'll be more in your homework, so okay. All right. Now let's talk about the ions that are called polyatomic ions. I've mentioned these before, but mention them again. On your chart, you've got the third column is a list of polyatomic ions. These are not all of them. These are just, some of the more common ones. And by the way, you will not have to memorize this because this periodic table is the same one you've been using on all of your tests all year long, right? So you're always going to have it. But, you'll eventually learn to recognize them quicker and be able to find them quicker. Okay. So the polyatomic ion is anytime you have 2 or more elements that are an ion. 2 or more elements bonded together that have a charge. Hence poly, many, which means many, atomic, ion. It's an ion that is made up of more than 1 atom. All right? And they have names, and so these are the names that you will use when you find them in compounds. So, SO4 is what we call sulfate. You do not change the ending on polyatomic ions. You only change the ending of elements. But a polyatomic ion has a given name. Do not change it. So, if you see this compound right here, BaSO4, that's barium, and SO4's name is sulfate, so this is simply barium sulfate. You look up the charge of barium, you see it's +2. You look up the charge on sulfate, you see it's -2, and that makes sense. That goes together. Okay? So, NaNO3. You know what Na is. Find the name of NO3. It is called nitrate. So you look up the charges. The charge on nitrate is -1. The charge on sodium is an alkaline metal, that's +1. Sodium only has one charge, so I don't need a Roman numeral for it, so I just call it sodium nitrate. So what's the next one? If SO4 is sulfate, the charge on sulfate is -2. The charge on potassium is +1, and there's 2 of them, so the charges make sense. Does potassium have more than one charge? No. So no Roman numeral. So this is simply potassium sulfate. Okay, so if there is a polyatomic ion, don't let that throw you. All right, you kind of still follow the same guidelines. The only difference is you do not change the name of the polyatomic ion. All right, let me go back to that blank space here and give you some that are a little bit more involved. Okay, so how about something like this? Okay, here's 2 compounds. They both have polyatomic ions. You have to look up the polyatomic ions to figure out their charge to help you figure out the charge on the metal, and then you have to name it. So give it a shot, see what you come up with. So what's the name for the first one? Yeah, good. Nickel 2 nitrate. So we'll first look up the charge on the NO3, and you see it's -1. And because there's 2 of them, that tells you the charge on nickel must be +2. And so you double check nickel and see how many charges does nickel have. Nickel has multiple charges. So that's why we must use the Roman numeral. Okay. How about the next one? Mattia? Yes. Sulfate has a -2 charge, and copper must be a +2, and copper has more than one listing, so that's why it's copper. We have to use the Roman numeral 2. And just for contrast, here's one. So ClO3, you have to look that up, find out what that name is and what its charge is. Nick?
Zinc chloride.
Yes. So ClO3 is called chlorate. It's got a -1 charge. There's 2 of them. So that means zinc's charge must be +2. And you check zinc and you see that zinc only has 1 charge. Because it only has 1 charge, we don't need a Roman numeral. So it's just going to be zinc chlorate. How are we doing? Good? Okay. So we're going to break this up. I don't want to lecture straight through. So now what we're going to do is we are going to go and pull down its homework. It's called homework 1. And we're going to work on some of those. And then we're going to reconvene and check them together before we do the next section of notes. Right, just to kind of make sure that you've got this. Once I find it, where is it? So homework 1, writing and naming formulas.